Welcome back. In this continuation of the New York subway data analysis in SQL, what we are going to do today is look at the tables again and see how we can join them. We'll also look at how we can subtract time to get the difference between the start and end time, or arrival and departure time. And the approach here is not to give you the final code without any explanation, but instead what I'm going to do is present the code as I attempted it, and where I failed, I'll tell you why the code failed and how you can try to write or try to get the same output from a different perspective, because this is a real world data set, and you can experience the complexities in trying to find very simple answers to very simple questions, just because there are so many things that can be different in this particular real world data. In toy data sets, everything is cleaned and put together. So if you say arrival time minus departure time, it will work perfectly. But as you'll see today, it doesn't always work that way. Additionally, when we say that in toy data sets, if we would say that if two columns have the same name, let's say station ID, you could join on station ID and everything will be just fine. But as you'll see today, there are other things that go on in the data set that makes you think how you want to join, when is the best, what are the best possible columns to use, etc. So let's get started. So here is the table layout, or sort of the schematic that we looked at earlier, where we have the table name here in up top in bold, and then we have the column names in blue, and in red color, these are the count distinct values for that column, distinct values. And so complex ID, so if you put a count distinct on complex ID, those are the values you get. That we would like to think that it indicates that there are 32 unique complex IDs in that table. That is a correct assumption, but at the same time, we also want to remember that there could be some values in that table that may not be complex IDs. Maybe there could be some bad characters in there. Those are also counted. So until we check that, we won't know. So, but what this tells us is there are 32 unique values in that column, and there are 32 total rows in that particular table. Likewise, if you look at the borrow code, it just has 5 rows. Now, the interesting part is between these two tables. Earlier, what I was thinking is that if we try to join these two, we could join it on station name. Additionally, there are other columns: division, line, then station longitude and station latitude. So, and finally station geometry. Those two column names appear in both the tables, and so we could do a join on that and everything works just fine. But that's not how it went. If we look at the distinct counts for division, here we have 4 and here we just have 3. Again, if we look at line, we have 34 unique values, here we just have 36. And again, the station names, as you see, there are very fewer station names in the station entrances table as compared to the stations table. And if you look at the latitude, longitude, again, those numbers vary. Additionally, what I found was that the latitude, the values were different in stations table and the station entrances table for the same station. That is something to keep in mind when performing a join with these tables. And to find out that this is the case, you'll have to spend some time. So I've spent almost a day just looking through this data set again and trying to figure out what all things are there. Next is, if we look at the stop times table, that's the largest table with around 500,000 rows, 550,000 rows. And in that we have around 20,000 trip IDs, and the trips table has around 20,000 trip IDs. So that matches. And so that tells us that if we join these two tables, trips and stop times, that join should be perfect. I mean, you have same number of trip IDs in both the tables. And from what I read, the trip ID is unique for a particular trip. And so the way you want to think about trip ID is, if I go from station A to station B and get a ticket for that, then that is my trip. However, if I get a ticket from station A to station C, where I'm making where I'm changing the trains at station B, then still my ticket is the same, but trip ID is also same. But what will happen is that in the same trip ID, we may see more than one routes, because you're changing the trains. Next is service ID. So again, I'll show the literature that I looked up. The service ID is used to create a trip ID. So part of the service ID is used in trip ID, and trip ID also has the date associated with that trip. Next, if we look at the routes, it's a small table, 30 rows, and we have 30 different route IDs. And those could be used here to join. Now, thinking about joining the tables here, these three tables on the right hand side to the tables on the left hand, do you want to do that? It depends on what you're trying to ask, what question you're trying to ask, because the routes table, it has route IDs, but you can have more than one route ID comma separated in the same cell. So if you are thinking about joining, you want to ask why you want to join, and then maybe you'll have to split that cell into 3 different rows. You'll create duplicate values in other cells, but then you'll be able to join on the routes table that way. Station names. If we look at the station names, here we have 355, and in this case, in the next table, we have 348. So there's a gap there, so we have fewer stations, and one would expect that the number of station names matches the number of station IDs, right? So that's not what we see here. Here we have 377 station names, but there are 493 station IDs, and that could be because the same station could have two locations. For example, earlier video we saw Wall Street has two stations at two different intersections, and so maybe that's why we have more station IDs, and that may be there. But I'm not sure why we have lesser stations across these tables. Maybe there's no data for those tables, or maybe those stations are just not functioning. Maybe there are no passengers there. Maybe they are under maintenance, something like that. Okay, and then there are these columns with just two unique values. So those could be either yes, no type questions, or just 0, 1 type values in these. Okay, so that's what I wanted to share about these. And the take-home message is that even though the column names are same, even though the column names are same between these tables, it doesn't necessarily mean that we can get the desired output after we perform the join. Now let's come back to the BigQuery notebook here, and what I've done is tried to put together some description details. The first is stop ID, so unique identifier for a specific stop or station. Stop sequence, that's the sequence of stops or stations with a particular trip. Head sign, so that's probably the sign in front of the engine in the train, the engine compartment in the train, the front, the very first car. Direction or destination where the destination where the train is going, or the next stop. That's what I'm thinking. Pickup type, there are two, 0 or 1, so regular or some special purpose, or maybe in this case I've written passengers are not allowed to board. Maybe it's a fast train and it doesn't allow boarding on stations between specific stops. Same thing for drop off type, 0 1, no drop off. Maybe train doesn't stop at those stations. 0 means the train does stop. And then we have service ID, that's a particular set of schedules, operating patterns for a transport route, and you'll see that the day of week is also mentioned in that. There are two columns that are empty: shape, distance traveled, and block ID. If we look in this particular table, that's the block ID, that's 0. Is stop head sign, and okay, so that's 3 of them. Then this is the last one that is also blank. Now let's try to answer some time related questions if we can, based on the table that we have. The very first thing we can look at, or the simplest thing we can look at, is to calculate the time difference between the arrival time and the departure time. If we have if we can get the difference between those two times, we can, for example, tell how many minutes or how many seconds does a train wait or a metro wait on a particular station. And for that, we'll simply try and explore how we can calculate the time difference. And as you'll see, initially it might seem a trivial thing to calculate the difference, like a simple task to do. For example, if we have this as arrival time and this as departure time, for example, if we run just that part of the select statement, we see that there's 2300 hours, 30 minutes. So that's 11:30 at night, and this is 11:35 at night. And if we get the difference between this, we can use the time underscore diff, departure time, arrival time, comma minute, and in the output we could see that there's a 5-minute time difference, and that's what we see. So looks pretty simple and straightforward, but as you'll see, it can get complicated very quickly. For example, let's say now uh, we have this table from which we are just pulling 10 rows, and these are the 10 rows we have, and in these, uh, at least in this case, we have the time that is 000, so that's all midnight. That is 12 o'clock at night. And if we try to get the difference between these two times, we should get 0 minutes. And let's try to run this. It's the same line of code that we have above. We are using the time diff. Now, in this case, the arrival time and departure time, here we had already converted it to time, so therefore we didn't have anything here. But now the arrival time that we have in the column, that is a string, and therefore we have to convert it to time, and therefore we are using this cast. So if we say cast arrival time as time, comma, and so that will convert this to a time data type, and then this will convert the departure to time data type. And we could do this. We could switch the order. We could, because departure time would be more than arrival time, and therefore we'll put that up front, so we get a positive value in the output. Now if we try to in the output, now we are going to get a look at only arrival time, departure time, and this difference columns. As we should see now, the difference that we have is all 0, and that looks fine because we are just looking at first 10 rows. Now it would lead us to think that everything is fine, and we can apply this to the entire column now and get the time reference. So let's try and do that. I'm commenting out this line and then running the code again. Now this time we run into a problem. What we have is an invalid time string. So instead of 000 for the uh, for midnight, we have 24 instead, and so that's a problem, and we need to fix that. So what I ended up doing is I ran into several such problems, and here is the code that I was this is how the code was evolving, trying to pick every edge case and try to solve it. So the very first attempt, what I tried to do was, if we get to 24, now here it doesn't say anything about the minutes and seconds. So I was like, okay, if it's 24, I can cast it to 00 time and then use that. But again, that leads to some other problems. Again, if we can use a regular expression. So sometimes this is 01 or 02, and sometimes these numbers can be 25, 26, 27. So there's several variations of this that we need to handle, and that becomes complicated really quickly. And apart from that, if you try to cast, so what this if statement is doing is looking for a pattern. If it's 240000 or likewise for the others, then we reset it to this time, just midnight, but we are not typing 00 because to handle the calculations, uh, so that we get the correct value. And again, we check for, if that's not the case, then we check if there are any other values in there. So that's why the dot star. And if that is the case, then there are several things you could do, and we'll look at them in detail. You could just reset this 24 to 23 and leave the remaining part as is. But that again creates new problems, because you are changing time. So if it's 24:01, 1 minute past midnight, and if it's incorrectly written as 24:01, and if you reset 24 to 23 just to handle the calculations, you are now looking at 1 minute past 11. So that could create some new issues. And so these were several attempts, and the code that I've written, I've spent a lot of time figuring this out. And so if you are working on a real world data set such as this one, uh, uh, I'd say be ready to face challenges uh, in the data, and spending a lot of time trying to figure a way out of that particular situation. So here is the sort of the approach that finally worked. Let's say we have an incorrect time, which is 2700 hours, 22 minutes, and 12 seconds. One option could be to just reset this to midnight and just ignore whatever happens after that. Right? So you don't really worry about what happens to the minutes or seconds, or if there is a time difference. So just reset it to this and be done with that. Otherwise, what we can do is just reset the hours part to midnight and leave the minutes and second as is. That's good. That could be done. Or we could reset everything to midnight. For example, this is 27, so we can reset the hours to 4. So hours to 4, I think hours would be 24 minus 27. So this would be 3. Mistake. So we could reset the hours to 3 and minutes to 22 and seconds to 2012. And so maybe the correct time would have been this, but then the data table has the incorrect time as listed in this one, and then we can use this to get a difference from 23. And you're probably already seeing this, that if you subtract 23 from 3, that comes out to 20 hours, and that's not exactly what we are looking for. We are looking for a time from 23 to midnight, which is 24. That's 1 hour plus 3, that becomes 4 hours. And we'll write a code that will handle all those situations. And before we get there, there's something else I wanted to share, and was thought I had the code up here, but never mind. Yes, so one with the I remember it now. There's one another thing that you could do is just drop drop the columns, drop the rows with incorrect time. Right? So that's an option, and if we want to do that, then uh, we'll have to find how many rows are there that have bad data in it. And we could try to do that. Let's say if I copy this and then paste it somewhere up here, the count rows with incorrect time. Let's put it there, and we don't need any columns right here in the output. All we care about right now is the count, and for that we'll write count star, and from this table, so we need the entire table, but what we are looking for is this, where, and we are going to check a regular expression to see if that is there in that string. If that string shows that part, then we count those. Otherwise, we do not count them. Count the other rows. And the regular expression then is going to be this, uh, where regular expression contains. Let's go down here and paste it. So what we are saying here is, if the arrival time, or this could have been the departure time, we could say or, and we could uh, copy copy and paste the same thing for departure time. Let's change this to departure. So this is departure. So if either of these is true, if we have an hour that is 24, 25, 26, or 27, then we are going to count the number of rows, else we won't count them. And here we see that the count is n is equal to 18092. So we have around 18,000 rows. And if we look at the total number of rows in that table, stop times, we have 5, 4, 6, 225. That's a lot. So select, we have 18092 divided by 546, 546, 225, and that comes out to how much? Multiplied by this, and let's run this. So we have around 3%, 3.3% of the records that are that we can call it as bad data or incorrect time. So you could choose to drop those rows that you'll have to decide based on what you're looking for, or you could try to correct the incorrect time and make some assumptions. Again, uh, would you want to do that? Would depend on depend on what you're trying to do. So let's say this is the first case where we are going to reset all the time that has 24, 25, 26, or 27 in the hour part of the time to this time. Uh, 59 minutes past 11, and then 59.99 seconds. So that's almost midnight. And to do that, here is where we start. We have this inner select statement. We just created one time, which is a departure time, that is incorrect time, and then we use that time in this select statement here. So we have that from that can pull the values of arrival and departure time, and then use that in the if statement that we have. So regular expression, we have the arrival time. We are checking if the hour part has 24, 25, 26, or 27. If that is the case, if this is true, then we replace the value by this time, else we leave the original time, original arrival time as is, and then rename this new column as a underscore time. Same thing we do with the departure time. And once we have that, once we have these two columns created, we can then use them in this outside select statement. So from this, the output of this would be now be used in the outside select statement, where we are saying we are simply taking the time diff, same as before, between departure time and arrival time in minutes. And the reason why we have this cast d time as time is because this is all of this is still in a string data type. So we are converted to time and then taking the difference in time in minutes as we see. So now if when we run this, we should get time difference. So here is what we have. We have a time difference, and the time difference is 58 minutes. Now, is that correct? That's the question you want to ask. 58 minutes is not correct because if you from midnight, this is if we reset it, we are looking at this, and so we have 1 minute that is past 11 o'clock, and then we have the midnight, so it should have been 59, and we'll handle that by using using manual calculation, little bit of manual calculation. And here is, I'll just copy this part and paste it up here. So let's leave that particular line as is. And so what we are trying to do is we are taking the time difference as we did before, but instead of minutes, this time we are getting seconds and dividing it by 60. See, and what that will do here, the reason why we are getting 58 is we are dropping the 59, that decimal part of 0.59, and that's why we are getting the 58. And we should have gotten 59 here. So when we use this particular setup where we extract or we get the time difference in seconds, and then look at and then round it off to get a nice round figure, we should see that we get the 59. So as you can see, we have 59. So this is one way to proceed, is just to simply take the whatever time is beyond 20, beyond midnight, reset it to 0 hours, and then get time difference. But that is going to create some problems because if the arrival time is we won't get the accurate values for those times because we are kind of manually setting the time back to midnight. But that's an option. The next option is this, where what we can do is take the take this is the timestamp, and we are uh, we are setting just the hour part to 0 hours, and then looking at we keeping the minutes and seconds as is. And so if we use that method, let's see what output we do, or what output we get. I'm going to copy paste this. Again, this is the same. Here we have the arrival time minus departure. So let's leave this as is for now. Uh, Again, this part is the same. Here we are checking if the hour part is 24, 25, or 20, 26, or 27. If that's the case, what we are doing is we are taking a substring of the arrival time, the substring of from the position 3 to position 8. So if this is the string we are looking at, this is position 1. Unlike in Python where we started 0, here we started 1. So this is 1, this is 2, and this is 3. So we are essentially taking this part with the substring and simply attaching this 0, 0 in front of it to get something like this. And so if these values are present, we reset it as like this, or else we leave the original value as is and return that. And up here, we then take the time difference between the departure and arrival time from these new columns that we create. So let's run this again. And as you can see, we have the output. And in the output, uh, so that there are several things that can go wrong depending on where the arrival and departure times are. Here we see that the time difference is minus 1358 minutes, and that's a very big difference. So I have the calculator in front of me. I'm trying to convert it to hours, and it's around 22.6 hours. So what this is doing is it's giving us the difference that we calculate is not correct because we are subtracting 23 from 0, and that's what's giving us this uh, uh, that's what's giving us this 22 hours of time difference. In fact, it should have been less than an uh, not less than, maybe just above an hour, because this is 11 o'clock and this is 22 minutes past 11 past midnight. So that's 1 hour 22 minutes. That's what we should have gotten. So this is an issue. If we have arrival time that is before midnight, departure time after midnight, then that is a problem that we'll run into, where we are subtracting 23 from 0 and getting an incorrect output. Again, apart from this, there are also timestamps where you have the 23, 24 in the arrival time as well, and that again adds to the complexity of handling this particular calculation. So what we can do is we can do is this, but before we get there, there's another option we can try, is reset this to this time. And what we that is, instead of changing hours to 0, we can change it to the whatever hour it is. So this would be 3, so 24 minus 27, that's 3, and that's what we can put here, and then get the difference. But again, even in this case, when we get the difference, we will likely get values that are not correct, because here we are taking a difference of 23 minus 3, so that's 20. and I'm guessing this 1178 divided by 60, that's 19.6 hours. So that's what we are getting, around 20 hours of time difference. That is incorrect, and this time diff by itself cannot handle the calculation with midnight, at least as far as I know at this moment in time. Maybe there is a way to do that with BigQuery uh, built-in functions, but we are going to try and do it manually. The first thing we'll do is, here are the steps. What we'll do is we'll get the difference of this 2300 hours with this time, which is just before midnight, and then whatever part is after the midnight, we'll simply add those minutes to that difference. So we get a complete difference between the arrival and departure time. And to do that, here is the code we have. This is the part that is the same that we had before. Now this part, it looks complicated, but it's the same stuff that we have seen above. This is our if statement, and the output of if statement is converted to time by this cast that's on the outside. And what the if statement does is it checks for these values 24, 25, 26, 27 in the hour part of the time. And if that is the case, what we do is we take the arrival time, we take the substring, we just take the hour part with this, convert it to an integer with this, and then subtract 24 from it, and convert that back to a string, and attach it to the minutes and seconds part. So if we have this particular string that we are working with, what we are essentially doing is taking this 27, subtracting 24 from that, so we get a 3. So we are taking that 3 and putting that in front of 22, just as we see in this down below here in the output. That's similar to that. Same thing we do for the same thing we do it for this departure time. And once we have these two columns created, a underscore time, d underscore time, we can use that. So if from this output of this, we can use that with this from in the select statement above, where what we are doing is we are checking if the hour part of d time is less than the hour part of the arrival time, a time, then we do the calculation in two steps. First, we take the difference up to midnight, that is 23:59:59, and the remaining part after the midnight that we have, that is this 22 minutes and 12 seconds. We take that and we extract the hour, minute, and second from that. So for example, if we have this 3:22:12, we extract the hour, that is 3, multiplied by 60 to convert it to minutes. And then we take the 22 as is right here, and then we take the 12 divided by 60 to get minutes, add all of them together, and add all of that to this difference. And that will give us the difference between the arrival and departure time. If the things are simple, that is there is no presence of 24, 25. If the time is correct, then we simply use the time diff, departure time, difference between departure time and arrival time in minutes. So that's a long code. Let's run this and see what we get in the output. So here is what we have. We have the time 2300 hours, and we have 27, so we converted it. So then after midnight is 3 past midnight, and so the time we are looking at is 26 these many minutes. Let's try and see if that is correct. So we have 1 hour from 2300 to midnight, so that's 60 minutes. Then we have these 3 hours, so that's 3 6 multiplied by 60, that's 180. 180 plus 60. So let me bring my calculator. So we have 180 plus 60. So that is 240 minutes. And on top of that, then we have this 22 minutes. So that's 262. And then we have the remaining decimal part with there. So this calculation looks correct. And we can use this code then for our calculation of time difference between arrival and departure times for the subway metro for various trips. And so what I've done then is taken that code we just had above and put it here down below. Let me go ahead and save this and put that query down here. And the only thing that I've changed is the from statement that's on in the inside. So here this time we are using the stop underscore times table directly, and initially we'll just set the limit to 10, so we have just 10 rows that we are going to look at. And here is the calculation we have. And I had put the, sorry, is there, yes, I had put the regular expression that filters the time so that we get the incorrect times for us to check the calculations. So here are the trip IDs. We don't need the trip IDs. I'm going to uh, narrow that column. And for this part, let's see, we have 2600 hours. So the arrival time is incorrect as well as the departure, both are incorrect. Does that affect our answer? So if we reset this to 2 hours 58 minutes 30 seconds past midnight, this is 3 hours 4 minutes and 30 seconds past midnight. So if we take the difference, we have, so this is going to be 2 minutes to 3, and then we have this extra 4 minutes. So 2 plus 3 is 4. We get the 2. Sorry, this is 2 minutes, and then we have the 4. So that becomes 2 plus 4, 6. That's 6 minutes. Plus, I would have guessed we should have gotten that 30 seconds added there. So 30 plus 30 becomes another minute. But uh, so let's see, we have 58 30. So 58, right? So that should be correct. We have 58 30. We cannot add 30 plus. So we have we start at 58 30, and so we end at 4:30, and so that's what gives us those 6 minutes. And now what we can do is we can run this query for all the records, which is around 500,000 records, and see if the code breaks anywhere, if we get some errors, or can this code handle all the data that's there in the table. So it and looks like this did work, and the code seems to have worked on all the data that we have. Let's take first for 200 rows, and so some of these timestamps for arrival departure are the same. I'm not sure why that is the case. Maybe the train doesn't stop at those stations, so it's 0 minutes wait time between arrival and departure. That may be the case, or there could be some other. And we can now dive deeper into this, trying to identify what is the distribution of time difference. How many rows have the same time difference, like the zero time difference versus other time. And here, yeah, this is just another, sorry, This is just to check if the above code works. We already did that, and now we can start using that. So I've created a CTE stop time where we have the code that was above, and we can remove these filters, and we can now use the column of time difference and trip ID to see if we can find anything. So let's try to write few lines here. First, what we'll do is we can uh, we can get maybe just a limit. Can get the trip ID, trip underscore ID, then get the arrival, or let's just simply get the t diff. That's the time difference. And why don't we just try with the first few rows, or just the 10 rows there, and we have this time difference. Now what we can do is we can check to see if of what is the proportion of each of these, and that's going to be tricky because there are going to be several values. If you put a distinct on this, those are float values, and they probably can take any value, and so distinct number of distinct values are going to be also substantially high. Oh well, maybe not. We have 15. Oh, we just have these many. So that is good to see. What we can do is we can order them, order order by t underscore diff, and then run this again. And remember, this query is now running on all the entire table of 500,000 records. And if in all the records, this is the wait time. Load more if there are any. I thought there were there? Here it says it should show up to 50 values. Okay, so we have 17 values there. So the wait time 0, then we have some values that are 0.5. This is all in minutes. Sometimes the wait time is 10 minutes. Now the next immediate question is uh, what is the proportion of each of these? And when we ask that question, we also would like to know if uh, if the trip IDs, how do the trip IDs work with this time difference? As we made an assumption earlier that if the trains do not stop at the station, maybe the time difference is 0. Is that really the case, or is it that the is it that it's an incorrect time? So let's continue looking into this. If we now want to find out the proportion of each of those stop times or the time differences, we can do that using the group by. So here I've already written the code. We have what we are doing is we're taking the count of the rows, number of rows divided by the total number of rows, or the entire data set or entire table, and we are grouping it by uh, t underscore diff, the column where we calculate difference between the arrival and departure times. So let's run this and see what we get. I've already run this, and uh, so there's some surprising results that you will see now. The biggest difference. So let me run the other query first. The query that I just ran, it has the difference in seconds instead of minutes, and I just wanted to first run the query that has the difference in minutes and that we have been working with. And the surprise was that over 96% of the records, as we can see, they have a time difference of 0. And I'm trying to make sense of this, why that is the case. I mean, it cannot be that 96% of the trains kind of uh, have so few stops that they start at station 1 and go directly to stations 2 without stopping anywhere in between. So I'm not entirely sure why this proportion is so high. Like, so if you have any thoughts, you can feel free to share them in the comments below. The other and if you look up on Google, the what is the average stop time for a New York Metro on a station? It is some, I've read that it's around 15 to 20 seconds or 30 seconds. And if that is the case, then maybe we are missing out on the decimal part here, and maybe that's why it's 96. And to check that, what we can do is get all the time difference in seconds. So I've made some changes. So I've put seconds where it was minutes, and so here extracting hour, but then multiplying it by 60, that converts it to minutes. Multiply again by 60, that converts to seconds. And here I'm extracting minutes, so multiply that by 60, and that gives us the seconds. And here we are directly extracting seconds. So if when we run this query, where we are taking the time difference in seconds and again trying to calculate uh, what values are there, we see that this still is 196%. So that again creates a new question. We're trying to solve we are trying to write the code, and every time we come up with an answer, it seems to raise a new question. And that's how the real world data sets are. It's so and at the moment, for us, looking, if you are watching this video, it's and without the description of the data set, it's difficult to answer the question why that is the case. But we can still try to look into this. What we can do is, I'm taking this query where we have the time difference in seconds, and trying to filter the rows so that we get only those rows that have the time difference of 0. And what that can tell us is what's so special about these values. You see, the train arrives at midnight, leaves at midnight, exactly the same time. Um, why is that the case? And if you look at the trip ID, you start seeing something. Uh, uh, what start seeing something like, for example, it says weekday, but then it doesn't say what day of week it is. Then you have Saturday, Sunday. Uh, so all Saturday, Sundays are there, but then yeah, there's nothing specific that we have right here. Um, Nothing. You have Wednesday. Then again you have weekday, and these are the times. I think these are the times 0950. So that time does not match the time that here we have here. So 0 hours, 9 minutes and 50 seconds. So this is 0 hours, 9 minutes and 30 seconds. So does this or is this supposed to be 50? I'm not sure. Again, the same thing here. We'll scroll up and look at these values. So this is all 00. That is all 00. This is 01. You see 01 minute, and that's 01 minute. Again, this is 02 minutes. This is 02 minutes, and so on. This is 02 and 50 seconds. So that doesn't match. All right. So that's what we have then um, with the stop times. If we'll look at the trip ID again in the next video, because the trip ID we can match it with the trips table, and then we can match that table output of that with the routes table, and maybe it will throw some light on why or what's happening here. So for now, we'll stop the video here, and we'll continue this discussion again in the next video. In this video, at least, I hope you got some idea as to how the code evolves uh, when you're working with this type of data. And this was a very simple task, just to find a difference in time between two columns. And it was as simple as this line of code. But as we tried to explore the code, we saw several uh, cases of data which we had to handle, and the code had to be modified to be able to handle that data. And even with this final code that we have, uh, it it may or may not work with um, new data that comes in. Maybe apart from 27, there is 29. Maybe there is 59 in there for hour. And if that is the case, then this part would have to be rewritten to handle multiple integers. I have hard coded these values, but then in those cases, it will have to be the regular expression would have to be changed. Right. I hope you enjoyed this video and continue to watch the upcoming videos in this project. Thank you. Please like, share, and subscribe. I appreciate your time, and it means a lot to me. If you find this interesting, I'll create more of similar videos for you all. Thank you.